Hello guys, welcome back to Mechanical Design Makers. In this video, we are going to see about fundamental dimension rules of Gd&T. There is 10 rules are there. We are going to see one by one. So watch this video fully without skipping to know about dimension rules in detail. Number 1. Each dimension should have a tolerance except those specific identified. Look at the drawing here. There is dimension 15 and 20. It have no tolerance here. As I mentioned before, any dimension supposed to have a tolerance. Without tolerance, we don't know what is the limit of the dimension, so that we cannot measure this part. Then how we can keep providing the tolerance? The first and most easiest method is mentioning the tolerance in dimension itself by giving plus minus tolerance. So we can give 15 plus or minus 0.2. Likewise, we can give 20 plus or minus 0.2. Or we can use general tolerance in the engineering drawing, mentioning all unspecified dimension tolerance is plus or minus 0.2. The next method is you can put the note to reference to international standards ISO 2768-1, ISO 2768-2. Please note this, these two standards only for ISO GPS, not for ASME standard. Number 2. Dimension and tolerance shall complete to full defined features. Look at the drawing. There is a two cylinder connected with rod. The diametrical tolerance of plus or minus 0.2. The diameter is 10 mm. This is theoretical part. Imagine when we actually produce this part, this cylinder and this cylinder will not be perfectly aligned as like this. There is out of control, misalignment. The next question is, how is allowed for this misalignment? Here there is position variation, right? The actual produced part is not perfectly aligned with the cylinder. Why? Look at the drawing here. This drawing only have the size tolerance. Size tolerance cannot control the position. The size tolerance is mainly used to control the separate size for each feature. So this drawing is not fully defined. We need some position control. How we can control that? If you are using ASME standard, you can give position tolerance directly to here. But in case of ISO GPS, you have to give position tolerance with the symbol of CZ, which means the confined zone. We will see the detailed explanation of the confined zone, because you can notice the position tolerance is mentioned without datum. See that? So we will explain this in later video. So let's have a quick review. The dimension and tolerance should have fully defined in drawing in order to produce good parts. Number 3. Dimension shall show the function of part shall not subject to more than one interpretation. If you look at the drawing here, you can see dimension provided between two center line. This kind of drawing is going to give more than one interpretation. How and why? Let's look at the center line. This is the theoretical part. These three hole and these two hole is perfectly aligned in straight line. But when we actually produce this part, there may be some variation. This hole and this hole and this hole have variation up and down, and each hole have the different center line, so that we cannot measure the dimension 20 because it gives more than one interpretation, because we don't know whether they have to measure from this pole to this pole or this pole to this pole and this pole to this pole, so that this drawing is wrong. Dimension should not give more than one interpretation. Drawing should define a part without specifying manufacturing method. GD&T is a functional dimensioning to design and dimension part. It should not specify manufacturing methods, because manufacturing method, for example, forming a hole, can be selected as per specific manufacturing site, such as drilling and milling operation. So let's come to overview. Drawing should not specify the manufacturing method. Number 5 and number 6 talks about 90-degree principle. A 90-degree applies where center lines and lines depicting feature shown at right angle. Look at the drawing. This line and this line is shown at right angle. Then this is 90 degree. That is implied 90 degree. A 90 degrees applies where center lines and lines depicting feature shown at right angle. Here, this center line is made to the basic dimension. So this angle is 90 degree. So the rule number 5 and 6 talks about implied 90 degree. Number 7. Unless otherwise specified, all dimensions are applicable at 20 degree Celsius. So usually we are setting CMM lab temperature at 20 degree Celsius. Number 8. All dimensions and tolerance apply in the free state condition. Free state condition means we should not apply any forces or giving distortion to the parts to measure the dimension. But this principle does not apply to non-rigid parts or flexible parts, such as a part made up of rubber is called flexible parts. This principle does not apply to this kind of parts. For those scenario, we have to apply this principle with restraint condition enabled, which means applying a force to a part to simulate its assembly or functional. For applying restraint condition, we have to use free state modifier. If this symbol is mentioned, free state condition is not applied. If it is not mentioned, the default is free state condition. Number 9. Unless otherwise specified, all geometrical tolerances apply to full depth, length and width of the feature. Here, the straightness tolerance is used. The straightness tolerance is applied to surface of the pin. It is going to apply full physical length of the pin. If you want to apply for a partial portion, you have to mention specifically. We are going to learn this in later. So let's come to overview. Whenever we specify the geometrical tolerance, it applies to full depth, length and width of the feature. The last one. Dimensions and tolerances apply only at the drawing level where they are specified. Any dimensions and tolerance mentioned in the component level is only used at component level, not for assembly level. Hi guys, if you like my video, please hit on like button and subscribe to my channel to learn more about Gd&T. Thanks for watching. We'll see you in next video.